You're being recorded. We record all of our meetings and post the meeting slides and other materials afterwards on GitHub at acm.org/archive. You can follow that link to find them if you ever want to look up anything that we did. Or if you missed the meeting and you want to rewatch the recording, those resources are always available. Also remember to fill out attendance at acm@uc.org/c. If you're not in our Slack workspace, it is the best way to connect with other people interested in tech at UC. You can find it at acmcincy.slack.com/signup. You can sign up with a UC email, and it's a fantastic place to get updates about what's happening in the tech community. Our office hours are also great if you're looking for homework help, or just to hang out and talk about tech, or just school things with people from ACM. Our office hours are Monday 5 to 6 p.m. and Thursday 2 to 3 p.m. So you can drop in on us then, or whenever you see us in the office, and we'll be happy to chat. Also, if you haven't already filled out attendance, please do so at acm@uc.org/c. It's how we estimate how much pizza to buy for meetings, and it's also how we determine voting membership. Voting members are people who have signed in to at least 2 meetings. We also have a code of conduct. You can find that at acm@uc.org/conduct. If you want to figure out any details of our policy, we also follow the UC code of conduct. So feel free to look that up if you're interested. Generally, just be cool, and we're all fine. If you're looking for work, we have a grad student from CEAS. I believe he's a civil engineering student who has an idea for a engineering design application. And he's looking for a programmer to help him with that. So you can reach out to him if you're interested at sonnybd@man.uc.edu. So feel free to check that out if you're interested in picking up some work. We also are going to present a draft of an amendment proposed to the ACM Constitution. This amendment has to do with the structure of Revolution UC as a committee within the ACM. I'll present and put up your text of the amendment for you, and you guys can read it, give feedback, and we will present the final draft based on feedback to you all at our next ACM meeting. And then the meeting after that, we will put it to a vote. So including this meeting, if you come to next meeting and you've not signed into any meeting before, you can be a voting member in time to actually vote on the bill. So let's go ahead and take a look at that. So I'm putting up here, you can see because we keep our Constitution on GitHub, you can see the commit diff for this. Basically, we are adding here a hackathon planning committee officially, which has never been official before. It's just been an ad hoc committee. And then here we are adding this section, which outlines the responsibilities of our hackathon planning committee. Do people have any questions, comments, or concerns about the proposed amendment? Yes. Why? Why? Yeah. Let's see. So there's some stuff about that people have put forward about formalizing the sort of the way that Revolution UC runs. I don't know, JT, do you have anything to comment since you drafted this?
Yeah. So the big thing here is, like you mentioned, formalizing responsibilities, and then also kind of splitting off the responsibilities of WC to an additional person on the exec board, and then also allowing the exec board to kind of have an approving voice on who the director chooses to influence for the event. So it's really just about formalizing that thing, and then also splitting the responsibilities.
Yes.
Does this mean the president cannot be the director?
That it's not said anywhere in the current text.
That's what it means. Yeah. You can't have a president also be the chairperson.
Yeah, so we had discussed that, and I actually looked at the text, and I don't think anywhere in the Constitution it says that. So,
President laws.
just a comment that it doesn't say, typically we don't elect exec members or appoint committee chairs to more than one position at a time, but I looked through the language of our bylaws, and I don't think it actually says that you can't do that. So, just a comment for people who are interested. Any other comments, concerns, things you want to talk about? All right. If you have any further comments or things you'd like to talk about, you can talk to me or JT or any of our other exec members between now and the next meeting, and we will discuss this and make some revisions to the text of the bill and present our final draft so that you all can have a couple of weeks to look over that at our next meeting. All right. We have a few upcoming events. Our next ACM meeting is on March 12th, same time, same place, and will be a talk by Sam Bouzas on RESTful API design. The NSA is also coming to UC, and they have an info session where they will be talking about various careers and ways you can get involved with them on March 4th at 2:30 to 3:30 p.m. in the Aircon studio. So check that out if you're interested. I also have flyers for that posted in Slack. Now I'd like to welcome Will up to the stage to talk about design systems.
All right, hello, welcome to my talk on design systems. First about me, I'm Will Cupp, fourth year computer science major, webmaster for ACM at UC, and I'm also on the Revolution Web team. I'm also the fall 2018 ACM Worst Website competition winner. I'd like to brag about that. So I'm going to be talking about these few things here. Designing for the web, problems that arise with designing applications for the web, design systems, and then how design systems can be solutions to these problems. So, designing for the web. What do we need for that? Well, HTML. You can make a website with just HTML. You don't need anything more than that, but it's not going to look very pretty. So, can we make it pretty? Yes, with CSS. Throw it on there, add some style, some color, some different fonts. It's all good. But what about interactivity? Well, that's what JavaScript gives us. You can make things interactive. You can have people interact with web content in new and different ways. Giving information to a website or getting information from a website. That's all bound together in digital experiences, and that's sort of what dominates the web, is users interacting with these different digital experiences. So, say we have a website like this. We have a logo up in the top left corner. We have a search bar in the top right corner. We have this menu on the left, this navigation menu, and in the middle we have a sign-up. Some HTML, we can easily put this together an hour maybe. We can add some color and stuff with some CSS, and then we could add some additional interactive features such as an autocomplete drop-down on the search bar, or warnings if your password is not the correct length, and then we could add some sort of pop-up when you click the sign-up button. So that's using all three of those, HTML, CSS, JavaScript together to make a sign-up experience for a user. So now what if you want to make a login screen? It'll look similar to this. What if you want to add a dashboard where a user can change their email preferences? That's going to look similar. A lot of copying and pasting of code will happen, probably, but that can be avoided. So say you're trying to design user dashboard interfaces, admin dashboard interfaces, online store interfaces, and some other miscellaneous interfaces. And you want to avoid copying and pasting code. Well, it's hard to do. Some of these problems that we're going to run into are consistency, efficiency, and scalability. This is an example of something that could happen if you're trying to code a large application by yourself. You decide to make a pop-up, you decide to make another pop-up, and then another one, and then another one. copy paste the code, some different use cases, but in the end, they all look different and can be confusing to the user. The UI is not consistent, and that is not good. So efficiency. So we've got 3 forms here: the sign-up form, the login form, and credit card information form. With something like this, the sign-up form, you implement it once, you go to the login form, you say, okay, I just need to remove some stuff. Okay, that's fine. No, you just copy and paste the code that you have, remove the confirm password, change sign up to login. Then you go over to the credit card information. Okay, just change what the label is from email to card number, repeat. Oh, and then you get down to expiration date and CVV. Suddenly you have an input that's only 50% with, you have to re-implement your login or your text box input as a new component. So that's not really a very efficient way of designing this. And that's another problem with designing scalability problems. So a developer or a team of developers working on 4 different aspects or 4 different parts of an application, that'll take a while. Usually something like this, where things are, parts of an application are siloed, they're very independent from each other, you'll have different teams working on that. Okay, that's good. But what about the interface? You have to have the teams communicate with each other so that they share their interface implementations. Make sure that they're all using the correct text color, stuff like that. Make sure that they're all using the same width for some sort of input. So communication can get garbled up, and people may not even communicate at all and just implement whatever they want, however they want, and then you get different styles of user interfaces for these 4 different parts of the application. To solve that scalability problem, they need to have some source of truth for implementing their user interface. And that's where design systems are good. So first, we're going to give a definition. I looked around the web, I looked really hard for about 5 minutes, and didn't find anything that I really liked. So I boiled down the definitions that I found to this. Design system is a design and style standards defined in documentation and supported by implementation. The documentation and implementation parts of this are going to be very important a little bit later, and we'll see why. So some attributes of a design system. They are rigid, meaning that rules dictate visual style, behavior, and interaction of components. And design systems are extendable, meaning you can easily create a new component that adheres to the style and design guidelines. So the rigid part means if you're going to include a date picker on a form, someone to choose their birthday or a date that they want to book a flight, it's going to be the same across an application. No ifs, ands, or buts about how to implement it. You take the component that's already been built by someone, drop that into your application, and that's how it's going to be. The extensibility part comes in with the guidelines. So if you don't have something like a drop-down menu, and you need to implement a drop-down menu, the guidelines of a design system will give you guidance on how to create that component, how the text should look, what the color should be, what the border thickness should be, what the border color should be, stuff like that, so that you can create a new component that integrates with the rest of the user interface that you're making for an application. So a design system will have some common parts. Guidelines. This is design guidelines or style guidelines. And these give guidance on the usage of color, typography, layout, and other visual elements for an application. The other part is the component library. And these provide concrete building blocks for creating a user interface according to the design and style guidelines. So we go back. The guidelines are the documentation, and the component library is the implementation. Now, many design systems have more than just these 2 parts. In fact, that most design systems have like 5 or 6 or more different pieces that make up the design system. So what are those other parts? A brand guide. This will tell you how to use a logo for the company, or what colors you're allowed to use, what sort of typography you need to use when writing out the brand's name. You have an illustration guide. This will tell you where you can use illustrations in an application and where you can't. Content guide. This will be more for marketing people than developers. It will tell them how to write copy text for like a website or an application and how to present that to the user. An icon library. It's just that library of icons for use in the application. So all these things on the left, they can stand by themselves as individual resources, but together they make a design system. So the goals of a design system are to solve the consistency problem. By having a component library where you can take a component and reuse that component in multiple applications, you solve the problem of UI being different across different teams, across different people who have implemented those UIs. Solve the efficiency problem. You can now have multiple teams working on different projects, and those teams don't have to communicate to each other about how their UI is going to look, because they all have guidelines in a design system that tell them what their UI should be like. And you've solved the scalability problem. You don't have to have a single person in charge of the UI across multiple teams. You can have each team in charge of their own UI. You can now have multiple projects being built in parallel. And design systems try to provide ease of use. And I'm going to do a demo just to show how easy it is to use a piece of a design system. Design systems in the wild. So this is a list. Google has the material design. Adobe has a design system called Spectrum. Salesforce, theirs is called Lightning. There's some other ones here. Some interesting ones are actually the USWDS and the WK design system. These are pretty strict in their guidelines on how to use them, because they have to adhere to certain accessibility standards required by law. So using those might be a little more difficult, or just because of the requirements for it. All right, I'm going to do a demo. Of the material design system. Oh, something will show up. So this design system, if you scroll down, you can see that they have the guidelines, the actual components, an icon library, and accessibility guidelines, and then components. So the material design design system has components for Android, iOS, Flutter, and full web. Many design systems are cross-platform, so it's not just web components. Actually, it is simple. It's copying and pasting this into the HTML file. So that's really all you need to actually import the web components for the material design system. You can then also import the icon library. And there we go, nothing. No, but we can start including some stuff in this page now that we've imported the components. If we go here and look at some of these components, let's see. App bar, yeah. There you go, one component. I'm going to add a few more just to show that we can also make it interactive. I have some stuff prepared. This doesn't do really anything interesting, it's just to show off how easy it is to include components from the documentation. So it looks a little funky there. Cool, now we've got some inputs, some buttons, stuff that we can play with and make interactive. It's also scales for mobile, so you know, no matter what the screen size is, most design systems allow you to do that. If you want to make it interactive, you can add just a little bit of JavaScript to do that. Nothing crazy. Hey, there we go, some JavaScript and some stuff pop on the screen. Oh, you guys have to see that. So I encourage you to check out Material Design. That's Google's design system. It's pretty cool. It looks nice. Also, the Fluent Design from Microsoft. That's pretty nice as well. All these design systems have a very flat feeling to them, and I like because they're, I don't know, I don't want to say copying Google, but I think Material Design is one of the first ones to actually have that flat, almost paper-like feeling to it. That's pretty much all I have for the demo and stuff. If you have questions, go ahead and ask. Otherwise, thank you.
All right, thank you for coming, guys. I hope you enjoyed the talk. Again, feel free to grab some extra pizza that's there. Stay and chat about the various goings-on in your college. Thank you again for coming. Make sure you fill out attendance if you did, and have a wonderful evening.